Well, students, we are discussing futures. We have seen what is meant by marking to market, and also we have studied the pricing of futures in the last class. In the present class, we will discuss hedging with futures. If you recall, we have already told that the derivatives are basically developed for hedging the investment. Since the future is a particular case of derivatives, the primary use of future contracts is to hedge our investments against the risk. Hedging strategy is basically a trading strategy made with the intention of reducing the risk involved in the investment or any commitment that is made through certain trades. Hedging strategies are of different kind and are of different complexity level. The most simplest one among all this is the perfect hedging. So let us try to understand what is this perfect hedging. In a perfect hedging, investors risk in a future commitment to deliver or receive an asset is completely eliminated by taking an equal and opposite position in the future market. If such a opportunity is available, let us illustrate this through an example. Consider an Indian tech company received an order from a US firm to develop a software. Say the order is worth $1 million, say at the end of August. That is the deadline for the project is the end of August, and assume that on 27th August the US firm will give this $1 million to the Indian company. Now, of course, the Indian company wants that money in rupees. And so on 27th of August, this Indian company, what they will do is they will convert this dollar into rupees. Say today, the rupee dollar conversion is say 72 rupees, 78 pies per dollar, say. Now, the question is, what will be the value of US dollar on 27th of August? That is the question. I think we have discussed already this example. The main problem with this company is to plan their execution of this project. For that, they need to have a clear-cut idea of how much rupees they will get as a revenue from this software development, and hence they want to know precisely what will be the revenue that they get in terms of rupees. So what they can do is they can go for a hedging either with forward or futures. For instance, let us assume that the manager of this Indian company goes for a future trade in the exchange. What he can do is he can sell $1 million in the future market. That is what we say is short $1 million in the future market. Say today the rate is 74.77 rupees per dollar, and this is the future price, not the spot price. The spot price is 72.78, say. What it means? It means the Indian company will sell $1 million for this price. Okay, so this is your future price in the future market, and the expiry is 27th August. So let us try to understand this future contract more closely. Assume that today is say 12th February 2021. A future contract with the expiry on 27th August 2021 is trading in the say National Stock Exchange at the rate of 74.77 rupees per dollar. Okay, and say each contract includes $1,000. It means what is the price, strike price of this contract? It is into 1000, so 74,770 rupees. Okay, so the Indian and the tech company has to take a short position in this contract. It means they will sell 1000 such contracts. Okay, where they will sell in the future market, say for instance in the National Stock Exchange or Bombay Stock Exchange, anywhere they will do this. Now the exchange will take a marginal deposit, say 10%, that is rupees 74 lakh 77,000 they will take, if it is 10%, from the tech company as a marginal deposit. Now, by taking this short position, what this tech company is achieving, let us try to understand that. For the sake of simplicity, we assume that the marking to market settlement is done only monthly basis. Remember, in reality, it is done on daily basis, but just for our calculation simplicity, we will assume that it is done monthly. It means you are already in February 12th, so you will have one marking to market settlement at the February end. Similarly, one more on March end, and so on up to August, right? Now assume that we are on 27th August 2021. Remember, we made the contract for the strike price 74.77. Assume that at the end of February, at the first marking to market settlement, it was say 74.72. Remember, each contract is for $1,000, so we multiplied it by 1,000. In March, say March end, it was 73.65. April, it was 73.03, and so on. This is May, June, July, and on August 27th, its price was say 71.44. Remember, at the expiry, you have f of t comma t. Okay, so this is your capital T, and that will coincide with the spot price, right? Therefore, the spot price on this expiry must have also been 71.44. Now, what will happen on this day? The tech company received $1 million from the US company, right? So what they will do is they will go to the spot market and sell it. What price they will get? At the rate of this one, right? 71.44. Okay. Remember, when they started this work, they were getting in the future market 74.77 rupees. Today, that is on August 27th, the spot price was 71.44 when the US company released that $1 million. Therefore, they have to sell it for 71.44 only. Okay. However, there is no problem, because since they have bought a contract for this amount, okay, they would have covered this difference in the marking to market process. How they covered? Let us try to see that. Let us try to understand this marking to market table. For every month end, we have a marking to market settlement in the exchange, and the time T1 corresponds to February end. Okay, that is where I told K equal to 1 means February end. Okay, that amounts to T1. On that day, the price of US dollar was 74.72. Okay. Remember, initially that is at f of T0. T0 is 0. is 74.77 rupees per dollar was the contract that we made, and on the end of February it has become 74.72, and therefore there is a difference between these two, right? So the difference, since you are in short position, you will have f of 0 comma t minus f of t1 comma capital T, right, into 1000. Okay, that is one contract. Like that we bought 1000 contracts, because the total money that we are going to receive is $1 million. Therefore you have to make this contract for $1 million. Therefore 1000 contracts we took. So this difference into 1000 square. Okay, so that gives us 50,000. And at the end of March, that is at T2, the strike price was 73.65. Okay, and that was multiplied into 1000 per, this is per contract, and that gives us this much money into the marginal deposit of the tech company. And similarly, on April end you have this, but you can see that in May from 73.03 to 73.71, the dollar value increased. Since you have a short position, therefore the increase in the price will give loss to us because we are in the seller side, right? Therefore there was a negative, that is, this much money is withdrawn from the margin account. Again it started decreasing, the price started decreasing. Since we are in the sell side, that again gives us profit. Therefore this is credited into the account, and similarly this. Now what you do, the total amount that the marginal deposit gained is the sum of all these numbers. The sum of all these numbers is 33,30,000 rupees. So this much money went into the margin account in addition to whatever is the initial deposit. Therefore, remember, from the spot market, the companies sold at the rate of 71.44. If you recall, this was the spot market rate. We got 7 crores 14 lakhs 40,000 by selling 1 million US dollars at the rate of 71.44 per dollar, plus our margin deposit increased by this much amount, that is 33 lakhs 30,000. So totally we got 7 crores 47 lakh 70,000. That is at the rate of 74.77, you can see. Therefore, on 12th February, whatever we fixed the rate, we finally got that rate on 27th August. In between, you can see that the dollar rupee price fluctuated in whatever way it was. It never affected the company in terms of its revenue. It got the revenue which it fixed on 12th February. Okay, irrespective to how the market fluctuated and what was the spot price at the time of receiving the dollars from the US company, irrespective to all that, on 12th itself they were able to fix what they want. And such a strategy in trading future market is called the perfect hedging. Next is the minimum variance hedging. If you see in the above example, we have fixed the $1 million receiving date to be the same as the expiration date of the August contract. Okay, and thereby we are able to perfectly match that hedging. But in reality, we may not get such perfect matching. Also, sometimes we may not get the kind of contract that we wanted with that price. Okay, in fact, see, this, since this is a dollar contract, so we could get it because in National Stock Exchange dollar versus rupee is trading, therefore it's not a problem. Suppose you go for some other country like Taiwan or some other country where our local market doesn't provide the direct exchange future contracts, then one has to go for some kind of complicated ideas. Okay, where our perfect hedging may not match accurately. In such cases, we should go for some kind of optimizing our hedging. Okay, so one way of doing it is through the idea called minimum variance hedging. Let us see how this works. Suppose that we want to trade an asset where the trading number of units is n. This will be negative if the trading is a long trade, and it is positive if the trade is a short trade. Okay, this is slightly confusing. Why we took like this is because we want to finally write the cash flow such that the cash flow is V is equal to N times S of T. Say, for instance, we want to trade at time T equal to tau, then it will be tau here. Okay, where this is the spot price of the asset, a single asset. Now you see, since we are writing it as a cash flow, this quantity should be negative if we are buying, because we are paying money and getting the asset. Therefore, the money goes from our hand. On the other hand, if we are shorting, that is, if we are selling the asset, then the money is coming in our hand. Therefore, this quantity V should be positive. That is why we take N to be negative if we are buying and positive if we are selling. It's just a reverse of what generally we understand the things, right? If you recall, in the last example, we saw that if tau is equal to T, if this tau is the expiration date and we wish to sell, then a perfect hedging involves taking short position in future contract on n units, right? In the last example, it was 1 million. But now our tau is the time on which we want to sell or buy the asset. So tau is strictly less than T. Then your spot price will not coincide with the future price, because the spot price coincides with future price or the expiration. Before that, we cannot say this, right? It may or may not happen. Therefore, we cannot do a perfect hedging. So it's not clear now how much unit we have to trade in the future market for the sake of hedging. That is the question now. Let us assume that H is the position taken in the future market with future price f of 0 comma capital T, with the expiration, of course, on capital T. For instance, this H was minus 1 million in the last example. Then the cash received during the period 0 comma tau is given by C is equal to V plus sigma I equal to 1 to n f of Ti comma capital T minus f of Ti minus 1 comma capital T times H. What are these Ti's? Ti's are the time at which mark to market payment is done. Okay, so therefore each amount is the mark to market amount. Okay, if you are in a short position, then hedge should be negative, and therefore it becomes minus of this. If you are having a long position, then hedge is positive, and therefore you will have this amount. Okay, see, you have to clearly keep in mind that this n which we are using is negative when you are long and positive when you are short, and hedge becomes negative when you are short and positive when you are long. So there is a slight confusion in this concept. You have to carefully keep this in mind, okay, and not make mistakes when doing problems on this. You can see that these terms get cancelled telescopically, and we get the total cash received during the period 0 to tau is V. This is the amount that we got by selling the asset at the time tau. Okay, in our previous example, we have sold $1 million that is received from the US company at the time T, capital T. Okay, at that time, that was the expiration of the August future contract also. But now we are not assuming that our, okay, so tau is strictly less than T is what we are taking. Okay, V is the cash that we received or paid depending on whether we are selling or buying the asset, plus f of tau comma T. In the previous expression, we have telescopically cancelled the intermediate terms in the marking to market payment, and we got this finally from the marking to market process times H. Okay, remember, unlike N, H is positive when you are in a long position and negative when you are in a short position. That also you should keep in mind. The aim is to minimize the risk by choosing an appropriate hedge. Okay, what is the aim? So the aim is this. Okay, we have to choose this hedge, that is the position. Position means the number of units that we are going to hedge. Okay, so that is what this minimum variance hedging will finally give you. What is your position? The position is hedge. Let us see how to get this hedge that minimizes our risk. The question is, what is risk and how are we going to quantify that is the first question before getting into this minimization problem. So one way of quantifying risk is to take the standard deviation of the appropriate random variable. Okay, so let us see what is the appropriate random variable. The appropriate random variable is C. Okay, so in this process, you can see that the cash received during the period 0 to tau is actually a random one. Why? Because it depends on the marking to market phenomena, and also it depends on what is the price of the asset at time tau, right? So we are interested in trading our asset at time tau. For that, we are entering into forward trade till capital T. Okay, but we want to come out of the trade somewhere in between itself. Okay, that is our aim now. So the cash received in this entire period is actually a random number. Okay, it depends on what is the price of our asset, which itself is a random number, and also it depends on the marking to market cash flow, right? So what is this appropriate random variable? C is the random variable. So for that, we have to first find the variance of the random variable. Let us try to find the variance of the random variable. Variance of C is equal to, by definition, expectation of V plus f of tau comma t minus f of 0 comma t into H minus the mean of this, right? Mean of C. F of tau comma t minus f of 0 comma t H, the mean of that, the whole square. So you can see that this can be simplified to V minus V bar plus f of tau comma capital T minus f of tau comma capital T bar into H, the whole square, right? Because this is already a fixed number, it will never change. Okay, you have already fixed when you are taking the contract, therefore this is a fixed number, so it gets cancelled with this one. Okay, this and this gets cancelled and you got this. So that gives us variance of V plus 2 times H covariance of V comma f of tau comma capital T, right, plus H square into variance of f of tau comma capital T. So we got the variance of C like this. You can see that the variance of C is a polynomial in H. More precisely, it's a quadratic polynomial. Now we want to find that H which minimizes the variance. It means that H which minimizes this polynomial, that can be obtained by differentiating this quadratic polynomial and then putting it to 0. That gives us the H as minus covariance of V comma f of tau comma capital T divided by variance of f of tau comma capital T. And this is called the minimum variance hedging. Remember, H is the position and this is called the minimum variance hedge. What is the corresponding minimum value of the variance C? That is given by variance of C equal to variance of V minus covariance of V comma f of tau comma capital T divided by variance of f of tau comma capital T. So that is a square covariance of V comma f of tau comma capital T square divided by variance of f of tau comma capital. So in particular, if your n is fixed, then remember V was written as V equal to n times s of tau, right? So if n is not a random variable, but it's a fixed number, then this n into s of t you can substitute here and n you can pull out of the covariance, and that gives us h is equal to minus beta times n, where beta is given by, so you just put v equal to n times s of t and pull the n out. Okay, then we will have n out, you will have s here, covariance of s of tau f of tau comma capital T divided by variance of f of tau comma capital T. Okay, so that is what we get here. So you put here beta and you get h, which is same as this, provided n is fixed. If you recall that you can write the correlation coefficient of two random variables x and y as rho of x comma y is equal to covariance of x comma y divided by the standard deviation of x into standard deviation of y, right? So we can use this in the place of covariance and write our beta parameter as the correlation between spot price and the future price times the standard deviation of S of tau divided by the standard deviation of F of tau comma capital T. So therefore, if you are given the correlation coefficient and the standard deviation of these two random variables, so you can find the minimum variance hedge, correct? Next is cross currency hedge. The cross currency hedge is same as the minimum variance hedging, but only thing is it is between two currencies. Recall that in minimum variance hedging, we had an asset, we want to sell or buy it at some time where its price is S of tau, we are trying to hedge it at some time zero in the future market. So it uses the correlation between these two random variables. Okay. Now the same thing may happen between two assets where you have a forward position in one asset and the forward position in another asset. And if you know the correlation between these two random variables, you can think of the minimum variance hedging between these two people. Just like how we did between these two, you can also do with these two. Okay. So in what kind of circumstances we can apply this idea? Let me just give an example. Suppose the tech company in India got a order from Taiwan company where Taiwan company pays 1 million Taiwan dollar to the Indian company for developing their software. Say, now how this Indian company will hedge? If all parameters perfectly matches, they may go for perfect hedging or they can go for the minimal variance hedging, provided if the exchange allows Taiwan dollar to rupee futures, right? If there is no future market which allows Taiwan versus Indian rupee futures, then what Indian company has to do is go for US dollar, Taiwan dollar future, and then parallelly they have to go for Indian rupee and US dollar future. So this is what is called the cross currency hedging. Okay, so let's call this future as F Taiwan 0, T, and let us call this as F Indian future FI. Okay, suppose at the time when the Indian company is seeking this forwards, let this be equal to 0.035 US dollars per Taiwan dollar, and say this is trading at 0.0134 US dollars per Indian rupee. Then you can see that 1 million Taiwan dollar is equivalent to $35,000. Okay. The Indian tech company may take a long position in $35,000 with a future price of this and a short position here. Okay. So in this market, you take a long, and in this market, you take a short and make a hedging accordingly. Alternately, what you can do is, if we know the covariance of the random variable ft and fi, okay, which you can always estimate, and the variance of fi, then you can again go for minimum variance hedging. Okay, I will leave this detail to you. You can just think of how to do this.